Optical fibres are used in endoscopes to see the body, and also they can be communications for light signals. And basically, the path of the light ray, it will be totally internally reflected across the boundaries every time it reaches the fibre boundary, even when the fibre bends. And when it reaches the boundary, the angle of incidence exceeds the critical angle of the fibre. And the idea of these optical fibres is to allow pulses of light then to one end from transmitter to reach a receiver at the other. The fibres need to be transparent to minimise the absorption of light, which would reduce the amplitude progressively as they went through the fibre more. Also, this is important when you think about what is actually in what is in an optical fibre. An optical fibre is a core surrounded by a layer of cladding, and the cladding has a lower refractive index, which reduces the light loss from the core. Light loss also reduces the amplitude. Total internal reflection takes place at the core cladding boundaries. At any point where two fibres are in direct contact, the light will cross from one fibre to another even if there was no cladding. The core must be narrow to prevent modal dispersion. This is the idea that light travelling along the axis could carry a shorter distance per metre than undergoing total internal reflection, because basically a pulse of light sent along a wide core will become longer than it ought to be, and this is to prevent elongation of the light wave. Also, there is another problem: is if it's monochromatic light. Instead of using monochromatic light, you use just normal white light. Basically, because different wavelengths travel at different speeds, you end up with something called material dispersion, where the different colours of light split up because they travel at different speeds. And the way to avoid this material dispersion is use a monochromatic light. And also, you could use something called an optical fibre repeater, which boosts the signals. Now, a medical endoscope actually contains two bundles of fibres, and a lens is on one end of the fibre to form an image of the body cavity. Now, the important thing there is that the bundle of fibres must be coherent, which means that the fibres ends at each end the fibre ends are at the same relative position, so the image is clear.